In 6.5, we're going to divide monomials. One of the first things we need to do is the quotient rule. Remember, we had the product rule where if you had two bases and you're multiplying them, you're just going to add the exponents. So if you had a to the n times a to the m, that's going to be a to the n plus m. The quotient rule is going to be pretty much the same thing, except we're talking about dividing now. So with the quotient rule, if we have a to the m divided by a to the n, that's going to equal a to the m minus n, and a cannot equal 0. So we're going to be doing pretty much the same thing that we did before. So if we had x to the 5 over x to the 2, that would be the same as saying x to the 5 minus 2, which is x to the 3. In the past, what we could have done here is said, okay, we have 5 x's on top, and we have 2 x's on bottom. Oops, x. And then what we do is cancel what we have on both top and bottom. So we have 1 on top, 1 on bottom, 1 on top, 1 on bottom, and all we're left with is 3 on top. And so that shows here we're just doing a subtraction. So something with numbers, that same thing, but with a number, say 3 to the 5 over 3 squared. That's going to equal 3 to the 5 minus 2, which equals 3 to the 3, which equals 27. For proof, what we can do is 3 to the 5 over 3 squared. 3 to the 5 is 243. 3 squared is 9. 243 divided by 9 is 27. Now, one thing here is if we have something like 2 to the 3 plus 3 to the 4 over 2 squared plus 3 to the 1, that does not equal 2 to the 3 minus 2 plus 3 to the 4 minus 1. So if we have a plus in here, we're not going to be able to do this as just each one separately. As proof, 2 to the 3 is 8, and 3 to the 4 is 81. 2 squared is 4, 3 to the 1 is 3, and that does not equal 2 to the 1 plus 3 to the 3. 8 plus 81 is 89. 4 plus 3 is 7, and that does not equal 2 plus 27. 89 divided by 7 is 12 and 5/7, and that does not equal 29. So if you have something like this, don't just subtract the exponents, even though we have the base is the same. You have to do what's on top individually and then do what's on bottom. Okay, so a few more examples here. Let's say we have y to the 7 over y squared. That's going to equal y to the 7 minus 2, which equals y to the 5. And let's say that we have numbers. Say 5 to the 9 over 5 to the 6. Again, something like this, it's to just do 5 raised to the 9 is going to be a huge number. So let's do the subtraction first, because we have the same bases, and that's what we have to have, is the same base. So 5 to the 9 minus 6, which equals 5 to the 3, and that's much easier to do. We can just do 5 to the 3. 5 times 5 is 25, times 5 is 125. Okay, so those are all ones that have just one base. Let's say, though, that we have something like 7a to the 4, b to the 3 over ab. Now here, it's not like that other example I gave because there's no plus or minus in here. It's all multiplication. So we can do all of these divisions. So I'm going to do them separately here, and then I'm going to do them as a proof just to show that we get the same answer. So 7 divided by 1 is just 7. And then we have a to the 4 minus 1 and b to the 3 minus 1, which is going to be equal a7, a to the 3, b to the 2. Okay, so if we were to do this where we separate it all out, expand it, we'd have 7, and then we'd have 4 a's and 3 b's, and we would have 1 a and 1 b on bottom. So we cancel what's on both top and bottom, this a with this a, this b with this b. We're left with a 7, and we have 3 a's, so a to the 3, and 2 b's, so b squared. So we get the same answer no matter which way we do it. This way, and you don't have to show all these subtraction steps. You can go straight from here to here once you know that you're just subtracting. Okay, so there's another a reiteration on here, and it's in this section a lot, of 0 as an exponent. Remember, any number that we have raised to the 0 is going to equal 1, but a cannot equal 0. So if we have something like 3 to the 0, that equals 1. If we have in parentheses negative 4 raised to the 0, it equals 1. If we have 7x to the 4y, all in parentheses raised to the 0, that equals 1. Now, here though, when we had the negative 4 in parentheses, let's say we have negative 4 raised to the 0. That's going to be negative of 1, so negative 1. Because remember, the exponent only affects what's right in front of it. So if we had something like 2x to the 0, that's going to equal 2. Because the 0 is only affecting the x, because there's not a parentheses surrounding everything there. Okay, so let's go back to doing some bigger numbers. Let's say we have 2 raised to the 3 plus 3 raised... Nope, I already did that one. Let's say that we have... right here is x to the 26, y to the 70, over x to the 19, y to the 15. So we have pretty big numbers here, but all we're going to do is subtract the exponents when we have the same bases. So we can compare the x's, so we're going to have x to the 26 minus 19, and y to the 70 minus 15. When we do that, we're going to have x 26 minus 19 is 7, and y to the 70 minus 15, which is 55.